So we're going to be starting off by tracing an algorithm. Now, if you have already studied modelling with algorithms as part of OCR MEI's Further Maths, or if it's something you are going to be studying, then this is something that you will either have seen and know about, or you will see very soon. So the algorithm goes through like this. First of all, you need to input a positive number n. We're going to be doing that with n equals 10. Then let a be equal to n over 2. Then step 3, let b be equal to 1/2 times a plus n over a. Then step 4, if a take away b all squared is less than 0.001, then we go to step 6. Step 5, let a equals b, then go to step 3. And then step 6, output the value at b and stop. So what I suggest is that you pause the video and have a go yourself. If you've not traced an algorithm like this before, best thing to do is just to lay it out in a table. You might want to watch a few more seconds and see me set the table up, and then have a go yourself, by all means, okay? So, the way that I'm going to do this is I'm going to set it up as a table. So I'm going to set up a column. So if we run through and we look at the letters that we've actually got coming up here, we've got n, and now I'm not going to have to put n, it doesn't change what n is, so I'm not going to put that as one of my column headers, but I've got A, I've got B, I've then got this stage here where I've got A take away B squared, so I'm going to have to work out what that is. I'm going to have to decide whether that's less than 0.001, and then I'm going to have my output, which I'm going to put at the end, okay? There's no one way of laying this out, just to be clear, okay? But this seems like a reasonable way to do it. So you might want to pause now and have a go. By all means, just watch as I work it through. So let a be equal to n over 2. So n is 10. So we've got 10 divided by 2 is 5. Then we've got b. So we have 1/2 times a plus n over a. So 10 over 5. And that's equal to 7/2 or 3.5. Now, when I'm putting my numbers in here, I'm going to round to 5 decimal places, I think. But each calculation, I'm going to use the full exact value, okay, as much as possible. So then I've got a take away b squared. So 5 take away 3.5 all squared is 2.25. Okay, so we're at stage 4. Is that less than 0.001? Well, no. Okay, so then, because that hasn't been agreed, that hasn't been cleared, we must go to step 5. Let a be equal to b, then go to step 3. So a then takes on the value of b, so a becomes 3.5. And then we're going to go to step 3, which is back to this one. So b is going to be 1/2 of a, which is 3.5 now, plus 10 over 3.5. And we get 3.17857. And I'm going to, as I said, I'm going to round that to 5 decimal places. Now the exact value for that is 89 over 28. Okay, so I'm just going to jot that down in case I need it. But I'll leave it there as it is. Right, then I'm going to a take away b squared. So 3.5 take away, now I'm going to use the exact value for this, 89 over 28 all squared, and we're getting 0.10332, okay, to 5 decimal places, which isn't less than 0.001, so no. So I've got to that stage again. So I've now got to put a equal to b. So I'm using that rounded value that's in there, but I will, of course, be using the exact value as much as possible through my calculation. Okay, so that's now my a. So I'm going back to step 3 here. So b is equal to 1/2 times by a, which is this 89 over 28, plus 10 divided by 89 over 28. Okay, and we get 3.162319, so 2 to 5 decimal places. So the exact value for this is 15,761 over 4,984. Okay, now I'm going to do a take away b squared. So 89 over 28 take away 15761 over 4984 all squared, which is 2.64 times 10 to the minus 4. So that's going to be 0.00026 to 5 decimal places, which is less than 0.001. Okay, so we actually go straight to step 6 now, output the value at b and stop. So b equals 3.16232 to 5 decimal places. Okay, so the question becomes, well, what does this algorithm actually do? And maybe that's something you were thinking about right from the start. Okay, so maybe have a little think of it first. Maybe pause the video, have a little think. Okay, so what this algorithm is doing is it is finding the square root of n. So this algorithm is homing in on the square root of 10. Okay, so this obviously isn't exactly the square root of 10, because square root of 10 is a third, but we're not going to ever quite get there, but we're going to get as close as we want to however many decimal places that we would like. Okay, so that is what this algorithm does. Okay, so the question then becomes, well, how good is this answer? How close is it to root 10? So we're going to come back to this example in a moment.